Good morning and welcome to this Greener webinar. My name is Rutger and I'll be your host today. In these sessions, we help you navigate the world of mobile battery power and we'll show you what's possible and how it works in practice. But today is a little bit different. We'll take a step back and look at what's happening in the energy transition and what role intelligent batteries play in that. Because the conversation is shifting, of course. It's no longer just about adding batteries for storage capacity, but batteries as intelligent assets. In short, electrotech. And today, before we get into smart batteries, it helps to look at what's driving this shift in the first place. First of all, the grid is becoming a bottleneck in a lot of places across Europe. Demand is growing fast as electrification is moving quickly, but the grid isn't keeping up. So you get congestion, limited capacity, and long waits or for new upgraded connections. And then there's the geopolitical side as well, as past few years have shown how quickly energy supply can become uncertain, which makes energy security, of course, a priority for businesses. And then rising energy costs don't help either, of course, because when prices swing, efficiency and control suddenly matter a lot more. And besides all this, there's the sustainability regulations that are getting stricter. But it's also about operating under new constraints and managing energy much more efficiently. That's exactly what we'll move into next. Because today I'm joined by our CEO, Jasper, and our technical sales specialist, Nathanael. Jasper will kick off with the bigger picture, the energy transition, why electrification is inevitable, and what role batteries will play in enabling that shift. And then Nathanael will translate that into practice. He will show how batteries function as intelligent assets within power setups, how optimization works through energy management, and he will walk through a real case study to show what this delivers in practice. And of course, as always, we would love to hear your questions, so you can drop them in the chat at any time, and we'll try to answer as many as we can at the end during our live Q&A session. At Greener, we operate Europe's largest fleet of mobile batteries, currently 250 units strong, and we're active across 14 countries. You'll find our systems in 3 main markets: construction, events, and grid support, or anywhere reliable power is needed, but emissions, noise, or grid capacity are constrained. In 2025 alone, these systems have already helped avoid 20,000 tons of CO2 emissions. But what truly sets us apart is not just the size of the fleet, it's the intelligence behind it, because every project is supported by our energy management system, which enables real-time monitoring, optimization, and data-driven decision-making at scale. Because intelligence in energy requires both hardware and data working together. And that's exactly what today's session will explore as well. Again, we want to encourage you to ask us any questions you have in the chat. And so with that, I will hand it over to Jasper.
Thank you, Rutger, and thanks everybody tuning in, taking the time for this session. So was asked to first talk about a little bit about the energy transition as a whole. I think it's very important. Every company should have a clear vision of what the role they play in society, and our role is very clear. We want to push the energy transition forward, and the energy transition has been top of the agenda for 10 years now, and I also think it's good to look back and to look forward where we are now and what's expected in the future. So as Rutger said, we really stimulate the debate, and that's why we kick off with a statement that people might agree or disagree. So very interested to hear what your take on this statement is. It's actually a fundamental belief at Greener that the energy transition would happen even if there were no environmental benefits. So let me explain. Taking a high level view, you can more or less pinpoint 2015 as the global kickoff of the energy transition with the Paris Accord agreement. This was very much driven by sustainability goals and sustainability benefits of electrification. If I talk about electrification, I'm talking about solar and wind generated or renewable generated energy. And I think that more or less you can pinpoint the next phase fairly clear as well as 2022 when Russia invaded Ukraine. So suddenly, especially in Europe, we were confronted with how dependent we were from fossil fuel imports and how vulnerable our energy system actually is because of that. And more or less overnight, the main driver of the energy transition shifted from sustainability benefits to geopolitical wish for more geopolitical independence regarding energy. And we're in the midst of this phase today, and it's probably been accelerated last weekend with the Iran war. And we're confronted again that our dependence is still, it's less than 2022, but it's still very much there. And with all the, say, effects that we have to deal with, one of which is higher energy prices, of course. So, of course, we fully embrace the sustainability benefits and also the fact that becoming energy independent as Europe or as the Netherlands, any country in the world, those are benefits that, say, we can almost classify as a cherry on the cake. Because we think that underlying is that the economical benefits will become, or already are to a large extent, but only will increase as the main driver for the energy transition. So in the end of the day, it's the fact that direct electrification is technologically and economically superior to a fossil society will be the main driver which will, actually make the energy transition succeed fairly quickly and at a global scale. So that needs some proof and explanation, and I'll try to give that in a limited amount of time. So if we zoom out, we all grew up in a fossil society, and we kind of take it for granted because it was just a given. And this is the case for more or less over a century now. But if you zoom out, it's actually very remarkable because it's a super complex system. And complexity translates directly into high cost. And this cost is rising because getting energy from harder places like the deep sea will just increase supply chain cost. This is just inevitable. And if you just picture the supply chain, it's quite amazing what we've built over the last century with very complex offshore drilling rigs, shipping it to refineries, which are gigantic industrial complex, then storing it into gigantic oil storage facilities, then putting it in tanker trucks and driving it to gas stations. All is very complex and costly, and then at a very large scale, and then it enters into a combustion engine. And the combustion engine in itself is a marvel of technology because it's basically a couple of thousand controlled explosions per minute with all the wear and tear of the parts involved. And also as a result, a lot of energy loss, especially into heat instead of propulsion. About 75% of the energy that's theoretically available from oil is wasted through heat, and only 25% is being converted into propulsion end of the day. That's just basic physics. And if you compare that very complex system with direct electrification, well, solar panel has no moving parts. You install it, it will generate energy for at least 20 years with barely any operational cost. Especially the low operational cost is key. This holds true for batteries as well. Yes, the uptime investment might be a little bit higher, but you have barely any operational cost over the lifetime of the battery. And the battery degradation is very limited, as we've learned over the last 10 years, way less than was expected 10 years ago. So also the lifetime increases and the cost of batteries decrease. The operational costs are minimal in itself because there are actually barely any moving parts. And then, we transfer through the grid. The grid is expensive, but again, barely any moving parts. So you put it in and you can run it for a century. And then it enters into an electrical engine of some kind. And that's also in simplicity far superior from a combustion engine. So I think it's good to zoom out and think about this new energy system, not just as environmentally superior, but also technologically superior, that translate into economically superior. We'll dive into that a little bit deeper and take a look at one of the main drivers, and that's the cost trend of, on the one side, it's diesel oil. And this is a chart over the last 25 years. And two things really are very clear instantly. Is first of all, it's kind of volatile. And, investors or anyone in business doesn't like volatility. It translates into unpredictability. Secondly, it's a rising cost. So diesel price in the Netherlands 25 years ago, roughly 65 cents. And now it's last week it was about 150, but due to the Iran war, it's now 195, which is actually exactly 3x of what the diesel price was 25 years ago. So yes, the diesel price might come down again. It will remain volatile, but the overall trend we strongly believe in is rising. Compare that to the right-hand side, where you see the red line, which is solar and storage cost. And two things are very clear instantly as well. First of all, it's super predictable. On maybe the hiccup in the supply chain due to COVID in 2021, but that's the anomaly. For the rest, it follows a very predictable cost curve, and the cost curve is clearly downward trending. So compare those two, and I think that solar and batteries, that's it's called storage in this slide, is in the cost sense way more predictable, and the trend is our friend. Diesel prices will rise over the longer term. Battery costs will decrease. So if you have this tipping point where the new technology, and let's take solar, because solar is about 10 years ahead of battery adaptation, so we can learn a lot of solar adaptation if we analyze the trend over the last couple of years, is that once you have this tipping point that the new technology is economically superior, which in the case of solar is clearly the case, the market will take over, and the market dynamics will really enable the technology to scale. And then you have this exponential curve of adaptation. And with solar, this is abundantly clear. So you see a fairly classic hockey stick, which is an exponential curve of solar being installed globally because the economics underlying are just superior. It's just cheapest form of energy generation. And what the yellow lines are the expectations based on different, say, well-known and highly regarded institutes about solar adaptation. And then you see how bad people actually are at exponential thinking, because it at best every expectation was kind of a flatliner or like an incremental increase, while reality was it was an exponential growth. And I think the same will apply to batteries, because there is this tipping point that batteries are economically superior, and we are at the beginning of that S-curve, is our strong opinion. So if we look at the cost of the different energy sources, you see that solar and wind is actually for quite a while already cheaper. To drive home that point, that's really economically driven. I'll skip a slide to make this point first. I think Texas is a great example. So Texas is not really known for a state with tree huggers. And Trump, we have a president that yells "drill, baby, drill" every time he talks about energy. But what's happening on the ground? What's actually reality regarding the energy transition in a state like Texas? Is they're clear front runner in the U.S. in both solar, wind, and battery adaptation. So I always say Texas probably love their oil, but they love profits more. And as a result of having an abundance of sun, having a lot of wind, having a lot of land, and little legislation, and then have the economics play out, this is what happens. And that makes also the energy transition, to me, very non-political. You can take it out of the political discussion and just look at it from an economical point of view. And I think that's really needed to accelerate the transition into the next phase. One major country that proves this should be done at scale, at huge scale, is China. They have adopted this reality of being also economically superior throughout their whole economy, basically. So if you want to look what an electrified society looks like, I always say you can fly to China today and learn from them on this respect, because they have electrified transportation, not just the cars, but the trains and the scooters on a gigantic scale already. And they really get it, and they are taking the lead. It's making them more energy independent, and also say sustainability-wise. I've used to live in China or in Shanghai 15 years ago. I couldn't see across the street from like 10 stories up. Literally not, because of the smog. Nowadays it's gone. So it's like hard proof that if you implement electrification at scale, you have all these three benefits at once, which kind of make it a no-brainer in our point of view. So it translates to the battery market. So I always say that solar, wind, and battery is like the holy trilogy of the energy transition, because yes, solar and wind are super cheap, but they're also quite unreliable. The sun doesn't always shine and the wind doesn't always blow. So you need a kind of a buffer in the system, and batteries play that role as a buffer. And there's a fourth element that needs to be mentioned, is that to have those assets work together in an optimized way, you need smart software. So that's where the energy management system comes in. So the battery market is bound to grow. This is a prediction that I kind of disagree with, because it's still incremental growth. I think it's an S-curve, so it will be much more exponential. But even in this quite conservative scenario, it's predicted to have a 70% year-on-year growth rate for the next 10 years. So how does that translate into our, say, economy as a whole? On the left-hand side, you see that 25 years ago, in 2000, only maybe 25% of the economy, electrification was economically viable. We're talking mainly about electrical equipment like your hand drill, stuff like that. That was already 25 years ago the standard. Fast forward to nowadays, you see that about 75-80% of the whole economy, electrification is the economically superior solution over fossil. That's not just for heating with heat pumps or with cars, of course, with EVs, but even trucking. 5 years ago, it was still the debate. It's not anymore. Trucking will become electrified. The debate now is more on shipping and on aviation, but there are already short-haul flights will probably become electrified. Shipping is becoming electrified quicker than everybody expected. And then what remains is like heavy industry. So I don't have a solution for everything, But heavy industry, the very energy intensive processes, like over 200 degrees, electrification is not yet viable. Maybe it's hydrogen. I'll stay out of that debate today. But let's just focus on the 80-20 rule, that 80% of the economy can and should and will be electrified already today. Then we'll make the transition to our say line of work, which is mobile batteries. So that's kind of a niche within the energy transition. We provide temporary energy supply, and the means to do it is the mobile battery, which is not just the storage of the energy, but also with the smart software, it's distributing the energy in the most efficient way, including managing how the supplies of the energy. But Nathaniel will talk about that at length in a minute. So what the battery is actually a convergence of two technologies. It's electrification and the digitalization trend, which is happening everywhere. So what excels the battery and what makes it such a good asset is that the convergence makes sense, that electrification and technology actually go very well hand in hand. I always say, like, the world of the bits and bytes really marry up very well with the world of electrons, much better than with fossil molecules. So that's why we call it electrotech, as the convergence of those two trends, which is actually kind of a revolution taking place and driving the energy transition forward. So super proud that we can play our role in this energy transition, especially in the niche of say mobile energy supply, based on the technologies that we are convinced of can really help not just achieve these sustainability goals or increase energy independence, but most of all just be an economic better solution than the diesel generator is nowadays. So with that said, I'll hand over, this is our mobile eye, which is basically the platform that we run our EMS on. I hand it over to Nathaniel, and you'll go deeper into the actual application itself.
Yes.
Thanks.
Thank you very much, Jasper. All right. So I'm Nathaniel, and I'm the technical sales specialist within Greener, and I will dive in deeper into this electrotech that Jasper's been talking about, and really show you why this and how this works with a battery as an intelligence asset. So we only own mobile batteries, which are just battery systems. But what we do is we put our own EMS on there, which is this hardware part. On this hardware part, there's our software running. And because of this, the batteries just aren't a energy storage system anymore, but they can be used as a power control unit as well and do way more stuff than just store energy. This software controls our battery, but it also can control all the assets. So, for example, solar, wind, a grid, generators of any kinds, so hydrogen, biogas, or diesel. And through this EMS, we can do so much more with it. Our software basically does three things, which is monitoring. It's basically getting all the data, see what's going on with the system and all the assets. It can do alerting, so it can give alerts when something wrong is one of these assets. And it can do reporting and also give insight into your data. We do that through our Greener project dashboard, where you can see all the data, what the assets are doing. You can generate reports on how much diesel you saved on your project, etc., etc. So, like I said, a battery, and in case of us, it's mobile battery, isn't just anymore a energy storage system, but also a power control unit. Because of our EMS, we can control all the assets, and based on that, we can generate the different kinds of setups and also optimize setups in every kind of way. with this EMS, we have a couple of standard setups. I will go quickly through that. And then I've got one case study where I show you a bit more in depth on an advanced setup where it really showcases how important a good EMS is. So these are our standard setups. On the top left, we've got our hybrid setup. This is just a battery combined with a generator. This generator can also be a diesel, hydrogen, or biogas. And what we do is we only turn the generator on when we need to. It goes off when the battery is full. And the most important part is that we utilize the generator at its most efficient way. Then we have peak save on the top right here. With peak save, we utilize a small grid connection. We use that to charge the battery, and the battery can be used as a buffer in order to provide big peaks or larger amounts of capacity needed during the day. Then on the bottom left, we've got load share, which is basically a combined solution of these two. So if you've got a grid connection, but it's not enough to charge the battery, then we can add an additional power supply, such as a generator. This generator will only be turned on when needed. And of course, we will use the grid first, and only when it's needed, the generator. And then on the bottom right, we've got our grid boost setup. What we do usually use this for is grid connections that are large. So we can also scale this to multiple batteries. I will also dive in deeper with this in this case. And we are then in a parallel mode, which we are grid following in. Great. All right, so now the case. We've got a customer that delivers packaging. During the holiday seasons with Christmas, you see that a lot of people are ordering presents for each other, and our customer really needed an additional power to handle all these packages. The only issue is here, they only have a grid connection of 3 megawatts, and they needed around an additional power of 1500 kilowatts, so 1.5 megawatt. Due to emission restrictions, generators were not allowed on site here, so we had to work with batteries as well. 1 point extra on top of this, they also had a 2 megawatt peak solar on the roof here that we could use. They could also feed back into the grid with that. All right, I'll quickly run through the current situation there, and then this is also the situation which is outside of the peak season. So we've got the grid connection on top here, then which is just providing the warehouse basically, and then we've got the solar here, and that can just feed back into the grid. This is usually more than enough to provide all the packaging and just run their usual operation. Now, of course, with the peak season, they needed a bit more, so we came up with a solution. The customer has 2 energy meters on site already, because they, of course, need to measure their energy and how much they are using. We are going to use these energy meters as well, so we actually connected to these external energy meters in order for us to see how much power they are using. Then we've added 7 batteries in order for us to provide the additional peak power and the capacity, the extra capacity that's needed, so also the kilowatt hours. And then we made 1 battery the control unit. So what we do is 1 battery is the control unit. All the 6 batteries are following this main control battery. And that main control battery is actually deciding which set points the cluster needs to do. So all the battery needs to do. So they are operating at 1 big battery, but 1 battery, the control battery, is the main controlling unit. That controlling battery, that's communicating with the energy meters on top here. It's gathering all the data that's coming from this energy meter and decides based on that data what the cluster needs to do. So if they measure here 3 megawatts, which is the maximum capacity they can use from the grid, if there's more power than the 3 megawatt, then the batteries, all the clusters, will provide additional power. If there's energy available, so there's less than 3 megawatt being used, then the batteries can charge. In this case, the solar is allowed to feed back into the grid. So what we did, if there's excess solar left, then we will first charge the battery. If the batteries are full, we will feed back into the grid. You can see what the batteries are doing in our projects. So on the top, you've got the state of charge, which is how full the batteries are. And on the bottom, you've got the converter power. So mind you, this is from one battery, but all the batteries are doing the same. You can see that during the night, here, it's charging because the operations stop, the people go home and there's no one working. So the batteries have got excess energy to charge. And you can see that the batteries then are full for in the morning. Then during the day here, you can see that they are draining a bit, but they are also charging a bit on this point here. This is because of the solar. So the solar also provided some additional energy. The load was probably a bit less, so the batteries had some time to charge again. Then during the day, they needed more power, so we drained the batteries. The batteries are providing additional power to the grid, and the warehouse could operate at its maximum capacity. At the bottom, you can also see this in the power trend, which is where you can see that they can charge here because there's a lot of power coming in, and then it's delivering power here at the bottom in the minus. This resulted in optimizing this setup and utilizing the infrastructure that was already there. So we utilized the grid connection at its most efficient way, so just in real time. We utilized all the solar panels that were on the roof. So the customer just had a stable operation and reliable operations. This, of course, really shows how the battery is in a power control unit, a really intelligent asset, and can control different kinds of assets and be really smart about this and use this energy smart. This is, of course, way harder with diesel generators because they don't really have the capacity to store energy. And that's why a battery can really outshine a generator here. I will now pass it back over to Rutger for the Q&A.
Yeah, that indeed brings us to our Q&A session. I see we have several interesting questions, so let's dive into them. The first one is, what do you think about the scarcity and the geotechnical independency of the rare earth metals needed for PV panels and batteries, etc.?
Yeah, that's a very good question. So batteries, of course, it's not like a. There's also some downsides for every decision you make in the energy transition. So yes, batteries, but there's good news here. So yes, batteries have some rare earth materials, but the good news is it's way less than before. So the amount of, for instance, cobalt that's going into a lithium battery nowadays is very, very limited, and there are technologies in development that require no rare earth material batteries at all. That still is more or less in the piloting phase, but the trend is really going in the right direction as well. That's one. So secondly, all the newer batteries are much more engineered to be recycled. So once we have these batteries within our, say, country or in Europe, and we have a good circular economy, recycling batteries is becoming. And here also, I think the economics in the end will drive the circular economy as well, because as these rare earth materials become more scarce, you want to reuse them also from a cost perspective. So that's bound to happen. Thirdly, is the duration, the lifetime of the batteries is increasing. The degradation is way less than was expected. So nowadays, an electric car you can easily run for 10 years. I have one that's 10 years old now, and I'll run it another 10 years. I think the degradation is not even 10%, probably more than 5. So these are all very important factors. It's not a perfect solution, but I think here the trends are also working in favor of batteries. Where the dependency remains, in my view, is much more a production of batteries and solar cells, which China is really dominant. So, and I don't see that change anytime soon. So Europe needs to be competitive and set up this production facilities at scale in order to reduce the production side of these assets. The rare earth material side, I'm less concerned about because of the reasons I mentioned.
I've even read about salt batteries.
Yeah,
something
sodium
at
batteries,
roughly
salt
another
batteries. They're testing. They're already producing some of the salt batteries. So I'm not sure if it's going to be the dominant technology. But the cool thing is batteries is such a big item. So globally, there's so much investment, but also brain power going into R&D in regards to batteries that there will be new solutions. And also because that's such a big market potential. So either it's sodium or it's another technology. All of them probably will be even less reliant on rare earth materials. So the main material in the current battery technologies is lithium. And lithium is not a rare earth at all. Actually, it's like ore, steel. I think it's the second most common element. So lithium, we have lithium in Europe as well. The difficulty with lithium is not the availability, but how to process it. Process it is quite dirty. So I do think you need to process it in your own country or your own region and not outsource it to Africa or elsewhere with all the negative effects on an environment and the people working in those facilities in developing countries. So yeah, very much for, and that's actually currently happening, especially in Portugal, setting up European lithium refineries. It's not rare, but the processing part is dirty and expensive, and we should do it within our own territory. Yeah.
Thanks. Then the next one, how does this relate to net congestion, grid congestion? And then the second part of the question is, and circularity resources on a world scale. But I think that's like what we
already covered.
Yeah. So grid delay, how does it relate to grid delay?
I think my case also shows this really well. This company needed an additional power for a short period of time. They of course can ask for a better grid, but it takes so much time. In this way, they can solve this issue with batteries, and then don't have to have the additional grid connection there. So there is enough power, but not at the right time. And with batteries, you can really easily solve that.
Yeah. So from an energy transition point of view, say solar and wind are 10 years ahead of batteries. So because of that, when the wind blows and the sun shines, there's an abundant amount of energy available. Actually, prices can go negative. So you can almost see it as a waste problem. Energy is dirt cheap, like in the middle of the day when the demand is low and the sun is shining at its maximum. So the grid was not built for this volatile energy production. But if you include batteries into the mix, then you have this buffer that mitigates this volatility. So we have to scale batteries, and that's 50% of the solution for net congestion is just adding batteries. And I'm not saying mobile batteries, I'm saying all kinds of batteries everywhere in the system. Very large scale stationary batteries, home batteries, connect EVs to the grid, and also our mobile batteries, neighborhood batteries, I don't know, but everywhere batteries in the system, then you have this big buffer functionality that kind of mitigates the volatility of solar and wind. And still we need to increase the grid also because of increased electricity demand due to data centers and due to electrification in general. So I'm not saying stop all those investments, but 50% of the solution is adding batteries to the system. Yeah, and I you see the net congestion. It's very similar to our road system. So you have this these peaks in the morning and especially the evening, when everybody is at home in the evening, turning on the television, start cooking electrically, putting on the lights, and charging their EVs, all when they come home, everybody at once. But then the sun is set, and if there's no wind blowing, then the grid is really stretched to the maximum. So you have the morning peak a bit, and the evening peak is very high, which is very similar to the congestion problem on our roads. It's in the morning, and so if we can also spread our energy usage towards more midday or in the night, you can. It's like the road system that you can be able to spread transportation during the daytime. You don't need to double every highway in your country because you just make better utilization of the highway during the full 24 hours instead of having everybody drive there during the 2 peak periods in the day, and the net congestion is exactly the same.
Next question. Do you sell new systems rather than just hire? Well, I can answer that. Yes, we do.
We do.
Next one. Do you have an idea, a figure to compare investments in solar and wind in the last few years to investment in fossils and mining? Perhaps at the same time, similar investments are being made in these.
Well, I don't have them really available now, but I do think I think that also, say, the large scale investors really start to get this narrative of that it's economically superior. So I do already see also the big money going into renewables. If you zoom out and you see there's way more being invested in renewables and batteries nowadays than in fossil. So that shift is already happening at scale. So and I think we need to embrace that. I think that also the big investments are required to make this energy transition happen, and these big investors are driven by economic incentives. And what I tried to tell today is there's this rationale to make these investments because it's economically superior. So I'm quite optimistic. I just think that still very often everything that's green or sustainable is instantly viewed as being expensive, or you have to pay a premium, and that's why adaptation rates could be higher. And also the second part, and this is a very big part, people are just change resistant. This is a new technology, and if you run a construction site or whatever, and you've done that with a diesel generator for 20 years, you really have to change your ways, and that's not easy. Especially with this new technology where software plays a major role. And it's like, everybody's riding horse and carriage 120 years ago. And then this car came with this combustion engine, and people were hesitant at first. But I see it's a bit of a branding issue, being green and being expensive. But I say green is not cheaper, but smart green is cheaper. So that's a branding issue. And the second thing is just change adaptation rate and make people embrace this new technology. And it's for us to make the technology simple and accessible. And that's, I think, what also Nathaniel tried to do today. These are very complex setups, but with the knowledge that we have and the fleet that we have, we can hopefully make it more accessible, and people start to embrace this new technology and see the benefits. And that's why, if it's data driven, we can showcase in numbers that it's the better solution.
I see there are more questions, but we're out of time. So what we'll do is everyone who had a question will get an answer as soon as possible in their email, in their inbox after the webinar. I think, Nathano, we can dive into that.
Yeah, definitely.
But that brings us indeed to the end of our session today. I hope you enjoyed it. Thank you, Jesper and Nathaniel, for joining us today. If grid delays are affecting an upcoming project that you have, please contact us. Our team can advise on an appropriate battery setup or hybrid solution, of course. And before you go, we'd love to stay in touch. Just scan the QR code on the screen to sign up for our newsletter and get updates on upcoming webinars and industry news and other insights from the Greener team. So thanks again for spending your time with us. We look forward to seeing you at the next one.